Hello everyone and welcome to my electronics channel. So in today's video we are going to talk about the ThingSpeak IoT cloud-based portal. Okay, so as you see here, I'm using a ThingSpeak channel to publish all my sensor readings from an IoT device and display as a visualization into this ThingSpeak portal. Okay, so the ThingSpeak, as you know, is a cloud-based IoT dashboard which is capable of showing any remote sensing readings from various devices across the world into a widget or a visualization, and you can see various kind of real-time visualization from various sensor readings. Okay, so it has capability to publish as channels, and it has the private channel as well as public channel. You can create some kind of a private view for your channels, or you can have a channel which is for the public view. Everybody in the world can see as long as they have this URL accessible to them. Okay. The ThingSpeak also has multiple apps and connectivity to various applications. So it comes integrated with MATLAB capability or your MATLAB signal processing and visualization capability. So once you provide the various sensor data to it, it will be able to analyze it, like create 2D or 3D plots or maybe bar chart, pie chart, histogram kind of a visualization, and you can represent those data or your sensor data into more like a graphical or a visual representation for easy analysis, understanding, as well as decision making. So in this like new era of the industry 4.0, where you have like like sensors and the data captured from various sensors across your devices published through IoT or your like various kind of data like analysis tools. Once you are like capable of seeing them, visualizing them, you can make various decisions to take forward as to, or you can apply various rules and functional logic to it. Okay, so multiple applications are available which can integrate to this like ThingSpeak. So it can also connect directly to various like, IoT devices with the help of either HTTP or like MQTT protocols, with the help of which you can like, publish like, events or like various kind of messages to the ThingSpeak, as well as you can subscribe to it. So both pub sub kind of a mechanism can happen. Okay. So in this example, what I have done here is I have used an ESP32 microcontroller to connect to the internet and a DHT11 sensor, which is capable of capturing temperature and humidity readings. And I've published those messages at an interval of 1 minute, which is 60 seconds, from the from my devices, which is the DHT11 sensor readings, directly into this the ThingSpeak portal, so that it can show more like a real-time visualization of the data as various gadgets like on this portal. Okay, so I'll quickly like refresh the screen to see where it stands at the moment. So as you see here, at certain point before 9 p.m. I shut down my my ESP32 controller like device, so it wasn't having any data from before 9 till 11. So after around say 11:17, it has started to capture the data once again, and the temperature is gradually increasing by zero point 0.1. The same thing happened for the DHT11 humidity readings. So just before like 9, around 8:50, 8:30ish, I shut down the device, and then I again turned it on around like 11:18 p.m. From since there it is capturing all the data. So ThingSpeak is providing you various like channels. It can have a private view, it can have a public view, you can have multiple widgets added to it. So I have added two new widgets. One is to capture the current temperature in degrees centigrade. So if you see here, 20.6 degrees is the internal room temperature here in Southampton. So it is able to capture the data here. And I've used this temperature gauge to showcase the current indicator as a meter. Okay. The same thing I have used for the current humidity, the values. And if you see here, all these are very much configurable. So each like, so each of these ThingSpeak channel, the free version of it, is capable of capturing 8 fields at a total. So I have used only 2 fields. One is to capture the temperature, other is for the humidity. So I'm mapping the field 1 into the temperature. I'm setting a min and a max value of 0 and 40, and I will be showing the value over here, so at the bottom of the gauge. The units are degrees centigrade, as you can see here, and I've used some kind of a color coding to display the various range of values. So for instance, 0 to 10 degrees is sky blue, 10 to 20 degrees green, then 30 to 40 is red, and so on. Okay, so based on these color coding, this is where it comes up. Okay, if the temperature recorded is say 9 degrees, it will be somewhere in between 0 to 10 in this range. The same kind of the visualization I have added on this humidity gauge. So if you see here, it is mapped to field 2, which is my humidity data from the sensor. The min value and the max value are 0 and 100 because it's a humidity and it cannot uh, range beyond 100 degrees or the percentage or the so 100%. So I'm showing the value here and the units are percentage. And I have just added one tick interval to indicate the various like 60, 70, 80, 90 degrees, all those kind of percentages. And one some kind of a like logical color coding. So if the humidity percentage is beyond 90, it will be red. So if you see here, that's how the gauge is being like rendered on the screen. Apart from these, apart from these gauges, there are some other like 2D line plots as well as 3D line plots, which is being used by MATLAB. For instance, I have used this 2D line plot to capture various the time-based data. You can actually show real-time data over here, and also the channel location. So every channel in ThingSpeak can have a particular location where it is like capturing the data. So I have used the latitude longitude of Southampton to indicate where the channel is located. Okay, so that's how a particular ThingSpeak a public channel is being configured. So as you see here, we have some API keys. So we have a write API key and a read API key. This is used to post the data from any applications or any kind of code into this channel. So whenever I will be using the ESP32 to post my sensor readings into this cloud-based portal, I have to use the write API key. Okay, so let's quickly go to the code. Okay, so if you see here, I've used the DHT11 as the temperature and the humidity sensor, and one ESP32 microcontroller to capture uh, the data and then transmit via the Wi-Fi. Okay, so as usual, SSID and password. This will be your the router, the SSID name and your password. So I'm using the DHT pin number 4 of the ESP32, and similarly all other configurations. So this is the write API key which I will be using. So now currently I have only one channel in the ThingSpeak. That is why my channel number is 1. If you had multiple channels, you have to set the channel number accordingly. So this is the same key which I have been configured in the ThingSpeak channel. So I will be using this key to post the data. Okay. Uh, the channel will be the channel will receive the data at an interval of 1 minute. So I have to specify like 60,000 milliseconds here. So the floating point variables, temperature and humidity, are being used here. Standard kind of setup code, the DHT.begin to initialize my DHT11, the temperature and humidity sensor, the Wi-Fi mode, and then because this ThingSpeak library is being used, I have to set the begin method as well. I'll do the read temperature call. So like DHT11 has an API to capture the temperature. It's one for the humidity. I've captured these two here. And then finally, so you have to set the field. So as I mentioned here on my channel, so I have two fields which has been used. One is the temperature, other is the humidity. So I am just setting the field, and then finally I'm writing the field onto the channel with the help of my write API key. Okay, so primarily that's the code. And once you get the channel update is successful, based on your the return code being HTTP 200, okay. Otherwise it will say there's a problem in the updating the channel. So very simple code, like mostly like anybody who is familiar with the REST API, so they will be able to understand how the publishing and subscriber model works. So as you see here on the serial monitor console, some of the data is being captured here. The temperature and the humidity as well as channel update has been successfully done. So very simple code here, and you can use it to sense any of your like devices, or maybe a robot, or even like any kind of like sensor readings into your ThingSpeak portal. Okay, so the benefit will be whenever you are not at home or like not at your like lab, you can remotely monitor the sensor readings from any devices, be it a machine or a smart home device, or even a robot which is capable of multiple sensors into your web-based portal. So a very interesting, a cloud-based portal with MATLAB visualizations to capture your data. Okay, I think it's very useful. Okay, I will want to showcase one small example where you can see. So as you see here, uh, so we are able to see the temperature reading and the humidity reading. So what I'll do here is, so I'll quickly capture the, so I'll quickly like increase the temperature of the sensor by slightly like blowing into it and see if the temperature and the humidity readings increase. So at an interval of 1 minute, it will be able to capture. Now just that I have like increased the the temperature, it should start reflecting the value over here. Okay, so we'll just wait for some interval and then we should see some spikes going in onto the temperature. Yeah, okay, so guys, if you see here, so we have one spike here where the temperature has increased to 21.7 degrees. Okay, and the humidity has increased to 94%. Okay, so earlier the value was like 20.6 degrees, and there's a big spike in the temperature range because I have blown some hot air into the sensor. The same has happened to the humidity readings. Earlier it was 74% humidity. Right now it has jumped up to 94%. Okay, because of the hot air being blown into it. So it is like near real time, and if we wait for a minute or so, we should see some kind of a spike down as well, because I've stopped blowing air, so it should gradually come down. Okay, so that is the way we can use the ThingSpeak as a sensor like reading being captured. So if you notice here, the second reading has also arrived. It has now jumped down to 21.1, and the humidity has also fallen to 82% from 94. Okay, so from 94%, it is now right now into like 74 almost. Okay, so I hope you liked the video. So if you found it interesting, please hit like and subscribe to my channel, and thank you so much for watching. Thanks, bye bye.